In this lesson, we are going to import the scene we already made in Blender, and we are also going to optimize it a bit. So the scene is already ready. We have our setup ready too. All we have in our setup is a cube. Actually, we have a bit more because we have the orbit control so that we can turn all around the scene. We have the white cube at the center. We are going obviously to get rid of it. It's just to make sure that it's working for everyone. We have that GUI on the top right corner. We're not going to use this one now, but it will get handy in the next lesson. We have the loaders, and we also have the Draco loader. All right, so if you did use Draco to compress your model in the last lesson, don't worry, it's going to work because we are using Draco already. We also have the texture loader, and we have the GLTF loader. All the loaders we are going to need in this lesson. The blend file from the previous lesson is available in the resources folder right here with the HDR baked texture, obviously, because we need it. You can use yours, obviously, but if you want to have the exact same file as me, you can just use this one in the resources folder. It's already open in Blender right here, and I put the exported file, which are the GLB and the JPEG file, in the static folder. So if you are using your own version of the model, put the baked.jpg and portal.glb you exported in the previous lesson in the static folder. All right, cool. We're going to do other exports now in this lesson. So yeah, let's go. I have VS Code running already. What we can start to do is load the model. So I'm going to keep the cube for now just to make sure that everything is working. But when I can see my scene, I'm going to get rid of this cube. So let's go. I'm going to create a new section just to kind of separate stuff. I'm going to call it model GLTF loader. So I'm using the loader that is already been created, instantiated before. And I use the load, and I'm going to send two parameters, which are the path to the GLB file, which is in the static folder right here. And the second parameter is going to be a function, and I can just make sure that it's working, loaded like that. All right, it's classic. It's what we did every time we had to load a GLB file or GLTF file. We just use the GLTF loader. We send the path. So the path is relative to the static folder. I'm not writing static. All right, don't put static. By the way, some people have troubles when they do that. It's going to work, but if you put a website online and your website has directories in the path, like I don't know, if it's a brunosimon.com/toto/subfolder, etc., and this is where my website is, you're going to have a problem because when you put the slash here, the path to these files become portal.glb. As you can see, we lost the directories, the path here. So if you want it to work, you can do like this, or just like this, and this will be relative. So it's going to look like this, GLB. All right, it's up to you. It's up to your website, the path to access to your website. But if it's in the same folder, maybe you should remove the slash. All right, that was just something I wanted to say. So let's see. I have my loaded in the console. If you have an error here, obviously pause the video, check what happened. You can have information using the error message. Maybe you got the path wrong. Maybe you name differently the file. Anyway, we can move forward. What I can do is get the scene we loaded. So I can send a parameter here and log it and do gltf.scene. All right, I'm just logging the scene we are being loading. That is being loaded. All right, we have some children in that scene. We have 56 children. That's a lot. We are going to actually change that later. And we can move forward. And what we can do is quite easy. We can add it to the main scene. So our scene. We add the scene we loaded to our scene. It's kind of strange that this is called a scene because it's the scene from what we imported, but it's not a real 3GS scene. It's just a group. All right, we've seen that already. So what do we get? Doesn't seem to be working. Actually, it is working. Look at that. It's just all black. And why it's black? Well, it's because we are loading GLTF model. GLTF models are using PBR material, and PBR material are being converted into mesh standard material. All right, it's the usual case. It's to get something realistic. So realistic, meaning we need light, but we don't want light. We want to use the baked version, the texture that will contain all information about light, shadows inside the texture. So we don't need light. We don't want mesh standard material. All right, what we are going to do is create another material. So it's going to be a mesh basic material with just a red color and apply it to every object in the scene. We want to just be able to change the materials of the scene we've been loading. We are doing that because there are many children and we need to put this new material on every children. So let's go. I'm going to create a new section before the model. Materials, yeah, why not? We are going to have multiple materials by the end of the lesson, so maybe create a section for that. So the baked material, I'm going to do baked material. This is the material we are going to use in every object of the scene we just loaded. 3 mesh basic material, so it's the most common material of 3GS because we just want in the end to put a texture on it. So it should look something like this. Yeah. All right, cool. No error. Yeah, no error. We can continue. And we are going to traverse the scene. If you remember, traverse will go through every children of the scene, even if you have children in children in children in children. So it's a good way of doing it. We don't really need traverse because there are no children in children. Still, it's a good idea. I want to show you that in case you have a more complex structure. All right, so let's go. We keep the scene add, and before or after is the same result. I'm going to do before because for me it's more logical. I'm going to traverse, and traverse you have to provide a function, and this function will be applied for every children and grandchildren. I'm going to put child here, and if you want to see, I can just log them, and you will see that I will get that much logs. So those are all the objects. All right, cool. And I can just apply the material on it. I can do child material equal baked material like this. Let me see what we get, and it's working. We are doing a small mistake here. We are applying the material on every children, even if it's not a mesh. It's not much of a problem. Maybe we have, I don't know, a group or something like that. It's okay because in the end we are going to get rid of this. All right. If we had, I don't know, like a camera, lights and stuff like that, we would have applied a material on those, which would have been strange. So it really depends on your project. Sorry, keep an eye on that. So for us, it's okay because in the end we are going to get rid of this. You will see why. Okay, we can see the scene. It's time to get rid of the cube. So remove all the code related to the cube. It's the object section. What do we get? Our scene looking like just a red silhouette. It's time to load the texture. And as you can see, we are going really fast. It's pretty straightforward. We're not going to have too much trouble in this lesson, you will see. We are just going to optimize stuff a bit. So how do we load the texture? There is no issue here. We are going to use the classic texture loader, like that. So I'm going to create a new section, even though we are going to have only one texture, I think. Yeah, anyway, it's always good to kind of do a fragmentate the code. So I'm going to do textures. I'm going to load the baked texture. So remember if it's this one here. So in the static folder, we did load the portal.glb. Now we need this one here. Baked.texture. I'm going to do texture loader.load and the path to load the baked texture. And yet again, I didn't put the slash. It worked. If I put the slash, I can show you. Baked. Oh, sorry, I put load. I put log. It's load. So as you can see, it's working. I can show you there. I have so much to show and no room to do it. So this is my bake texture, and if I remove the slash at the beginning, it's working too. But it's because we don't have a path. All right, so it's up to your URL, and if you have a path in it. All right, I'm going to do like the model and don't put the slash at the beginning. Okay, cool. We can now use that texture in the mesh basic material instead of this red color. This was just a test to make sure everything is working. So I'm going to use the property map. It's just like the first lessons of 3GS. And I'm going to use the baked texture in the map. And as soon as the texture is loaded, we can see it. And what's happening here? No, it's not. And I didn't like messed up with the file. It's kind of a bug. You will see what exactly is happening here. The first time you see that, it's a nightmare because you really don't know what's happening, and good luck to understand what is happening here. I can tell you what's happening. It's being flipped. It's being mirrored like this. And good luck to find out this. I know I spent hours the first time I had this problem. I just spent hours trying to guess and trying and simplify the model as much as possible. And at a point I was like, but it's just inverted. I think I did it. What I did is that I put it in a plane, I exported it, and it was the opposite of what I wanted. I understood that it was just flipped. It's doing like that. All right. I don't know why exactly like softwares and library and stuff like that don't agree on the direction. So is the Y should it go up or down? I don't know exactly. It's about coordinates, stuff like that. But sometimes you need to flip the textures. All right. And it's on the Y axis. To do that, it's quite simple. You do baked texture, flip Y equal false, because by default it's been flipped. So we unflip it and we get this, and it's looking good. See how fast we got it working inside the 3GS, and it's really good, but it's not perfect. We need to do some improvements, and maybe you can see what. The first one we are going to see is about the colors, but the colors are great. No, they are not. We need the perfect color. We need the exact color we had when we did a render. Your client will say it's good, but it's not like the renders. And you promised, yeah, you will get the exact same technique because I learned a technique, the exact same render because I learned a technique named baking, and you will see it's gonna be the exact same thing. And it's not, as you can see. We have a problem here. It's not the exact same color. They are kind of more dark, more contrasted, less grayish. How do we fix the colors? Actually, you probably know about that. We talk about that. It's all about color space. It's all about encoding. We need to fix the encoding. First, be aware that when we saved the JPEG file, it was in sRGB space. We didn't have to specify this, but when we saved from Blender, I think by default it's the parameters. The parameters are like this, but it's sRGB, which is great. It's what we want. Sometimes you want different color spaces, but the default one that gets you good result, and it's the most common one, it's sRGB. But 3GS doesn't know that. All right, it looks like it's not encoded in the image, so 3GS just doesn't know about this. So we need to specify it. We are going to do baked texture, encoding, and we are going to use 3.sRGB encoding, like that. And it's worst. What's happening here? It's even worse. Did I get something wrong? No. It's because we also need to tell our renderer to output in sRGB. So we input sRGB textures. We say to 3GS, these are sRGB. So 3GS will now handle those using sRGB space. But we need to say to the renderer to now output sRGB colors. So to do that, you have to scroll down to the renderer here. And anyway, it can be before or after those set size and set pixel ratio. Renderer, output encoding equal 3 sRGB. It's exactly the same, sRGB encoding, like that. Never mind. Oh, it's output. I forgot a T. Yeah, and now it's exactly the same as in the render. I know it's not a huge difference, but for me it has to be perfect. All right, and it's what most tutorials you can see about baking get wrong, and I've been doing it wrong for so long, and now the colors are perfect. Okay, cool. We have other problems, as you can see. Even if it's looking cool, like it feels like you're looking through a portal that gets you an unwrap world. Okay, it's fun, but it's not the result we want, especially for those lights. So we need to fix those emission objects. Remember, we choose not to bake them because it's just one uniform color. White here for me, so for you it might be different if you use, I don't know, pink, blue, green, and some kind of orange, really bright orange here for both lamps. All right, let's go. We are going to start with the lamps, and we're going to have a problem. But first, let's create the material. So it's going to be the same material for the two lamps because it's the same color. If you have two different colors, obviously you can change them, but I did use the same, so I'm going to do pole light material. Const pole light material. Yeah, it's quite long, but I like long variables name. Mesh basic material, and we choose a color, and you can choose my color. All right, we are not going to create a tweak for that. If your color is different, obviously you will have to test something else. Maybe you should pause the video, create a tweak for this one, and find the perfect color. It's up to you. You can also just use like the color picker on your render and get the color inside the lamp. All right. So for me, it's this one. If you use a similar color, this one should do just fine. All right, we created the material. No error, we can continue, but we have a problem. How can we apply this material on those two objects? If you remember here, I'm going to log all of the children of the scene. Well, yeah, this is the scene. So we have a problem. We cannot distinguish them. But as you can see, each one has a name. And I can show you that on Blender. Look at this. They all have a name. And it's the default name. Remember, I told you we don't need to change the name. Not yet. It's not that important. Usually I don't change all the name because I would spend hours just changing the names. And when I create a bunch of new parts, I'm not going to name this one Jeff, Jerry, Tom, and stuff like that. I put random names. I let the default names, but I put everything in collections. But now we can use the name to be able to just target specific objects. And we are going to do that only on those objects. So this one, and this one. So open Blender. Let me check if it's what's following. Yeah, open Blender. I'm going to use mouse and numpad like this. So you can do without mouse and numpad, but it's so much better. And I'm going to rename them. So if they are, if you can't select them, obviously it's because you checked this, which is great. But now we need to select them. So make sure you can select the emissions object. And is there something else? No, I think this one is just fine. Yeah. And I'm going to change this one, and I'm going to name them. So pole light A and pole light B. Pole light B. By the way, in Blender, you cannot use the same name. See if I try pole light and pole light again. This one got renamed pole light 001. It's because the name in Blender, it's like a unique ID. All right, it's assumed it's like that. They are used like unique IDs, which is great. But when you start and you just try to use the same name, you got some problems. So I cannot just use polite on both. And if it's polite, I apply the material. We have to use different names. We could have used regex. If you don't know about regex, it's kind of a way to search something, and I would search for a name starting with polite. It's usually what I do, but I don't want to bother you with regex. We only have 3 objects. Let's put 3 different names. And this one is going to be portal light, and it's good. All right, I think we are fine. We're going to select everything again, not everything, because we are not selecting the camera and the light. Actually, if you export using the default settings we had, you would see that the camera and the lights are not being exported. Still, I like to put things I don't want to export inside a special collection, which is, for me, others. All right, everything is selected, looking good. I'm going to export that. GLB. Here are my settings. These are the default the settings from the previous export. Pause the video if you want to make sure you have everything the same. I'm not going to use the compression because, as I shown you in the previous lesson, it's bugged with this specific version of Blender, so it's 2.92. So no compression, but it's okay because the whole model is optimized and very light. And I'm going to put that inside the right folder. So for us, it's in the static folder. Make sure you're inside the right folder. The static folder, portal.glb. And I export like this. All right, cool. Let's get back to 3GIS. Be careful when you have both Blender and WebGL running. You're kind of like really pulling a lot of power from your computer, especially if one of them is using like the render. So maybe at least move to just solid or material preview. Solid is fine. Wireframe 2, and it should be fine. We are going to get back to Blender, so don't close it. Okay, cool. I can just like refresh, and let's see if I can find them in the names. Let me see. I'm going to get back to my trackpad. Yeah, here in the end, perfect. We have the pole light A, portal light, and pole light B. Okay, cool. What we can do now, we could have do it in the traverse, and if the name is this one, then we change the material. But I want to show you another solution which is not related to 3JS. It's more related to classic JavaScript. It's by using the find. Find is a method you can use on arrays to find something according to a condition. So to write this find, you can do a if here. You can do a condition here. If you're not like comfortable with find, just do it inside the traverse. But we're going to get rid of the traverse, so I recommend you to learn the find. It's very powerful, but it's way too complex. You will see why. GLTF, actually you probably already know how to use find, but still it's a good opportunity to learn it. GLTF seen children, so this is the array. All right, find can be used on arrays. I can show you this. All right, this is our array with every object. We want to find the one named pole light A. How can we do that? We can do GLTF seen children, so it's the array, find, and we can send to it a function. So I'm using arrow function, and this will go through like a traverse in a way every object, every elements in the array. So I'm going to call it child, and actually I can just log it, and you will see that it will work. So it's going through every object, every element in the array. And if here we return true, if we just return true, it will stop, and this function, this find, will return this element of the array. So because I just said this will return something, the idea is that we are going to create a variable. I'm going to call it pole light A mesh equal this. Pole light, let me check. Yeah, it's exactly that. Pole light A mesh equal the result, what this find method will return. And this find method, you send a function, and if at a point it will go through every children, and if at a point it return true, this will be what will be assigned to the pole light A mesh. Kind of hard, but really useful once you understand how it works. So what I can do here is return child child.name equal triple equal, and it was pole light A. Yeah, so this will be sometime false, sometime true. So if the name is pole light A, it will be true. So it will go through every children, and at a point it's going to be true. This will return true, and I will get this element inside this variable. So we can try. Maybe I got something wrong. No, it's working. See, I got this mesh, and this mesh is the pole light A, and it's working. So this is one way of doing it. It has almost nothing to do with Three.js. It's just the find. By the way, you can create a more simple version, which is great because it really get kind of shrunk. When your function, it's an arrow function, and all it does is return something. Here, the only instruction here is to return something. You can remove the return and remove this curly bracket. So I'm going to remove the return, remove the curly bracket, and because it's looking like this, I can also remove the line breaks like this. See, I'm going to test again, and it's still working. All right, and now it looks really like short. By the way, if you have only one parameter in an arrow function, you can also get rid of the parentheses like this. All right, it can be very light to do a find like this. I'm going to do the same for the other one. So it's going to be the B. And here the B, I'm going to test it because I'm not sure of what I'm doing. Always test, you get the right object. Yes, and before, I don't know why before, but anyway, I'm going to get the portal light mesh, and here it's going to be portal light. I think I got it right. Let me check. Yeah. So if you don't get all the three objects, all the three meshes, pause the video. You did something wrong. I went quite fast. We learned the find, stuff like that. So just pause the video. Make sure you have the same code as me. Make sure you did export everything and you put the right names in Blender. It might be the problem here. Maybe you got a name wrong. So make sure of that too. Now that we have the objects we need, we can change those objects material. So let's go. We don't have the portal light material yet, but we do have the pole light. So let's go. I'm going to do pole light A mesh, yeah, dot material equal pole light material. Those names are getting like really complex. And for the B, and let me check. Yeah, it's working. See, I only changed this one and this one. And this is kind of what I do in for real projects, really. I just usually use more regex because this way I can like select all the pole lights. So it's all the meshes starting with pole light, and I don't care about the rest using regex. But yeah, I do use that a lot. It's sad that we cannot add more data easily. There are some ways of doing that, but it's not very good to add data like in Blender and export them and get those data in Three.js. It's not working really good, so I use the names usually, which is really limited. But anyway, let's move forward. We can create a portal, obviously, because even if I really like to see this baked texture, we want like a real portal. For now, we are going to create a material, like a mesh basic material, but later, so in the next lesson, we are going to create a shader. It's going to be a really cool shader. You will see how cool it is. You actually probably saw it in the previous lesson when I did a preview. So yeah, let's go. Portal light material, const portal light material equal new 3. I could have like copy and paste. You know what? I'm lazy. poof, 0x, and it's all white. Obviously, if your light is different, you will have to change this. But remember that we are going to do a shader later, and we will have to send uniform, color uniform, stuff like that. So if you want to find the same color, to put the same color as you, do it, but don't spend too much time on it. We are going to get rid of this one later. So I did create the portal light material. I can now assign it to the material of this mesh. So let's go. Portal light mesh dot material equal portal light material. So it's exactly what we did for the pole light. And we get this. Yeah, funny thing, when we load the scene, while the texture isn't loaded, we can see the lights and then the texture. It's because the texture is quite big. Let me check, by the way, how big it is. Yeah, see, it's almost 1 megabyte. So yeah, it's quite heavy. You don't need such a heavy texture, but I wanted to make sure that it's looking great for everyone. So I told you to create like a huge resolution texture. Okay, it looks done, but we did some performances issues here. We did some errors. Always keep an eye on this. It's important. This, I think it will work on any devices. Still, if you start to add some details, some more complex scene, maybe you have other scenes on the side, at a point it will work only on good computers with great GPU, stuff like that, and it's not what you want. The good thing with WebGL is that you can just click on a link and get your experience. It's great, but if it's not working on your mobile or stuff like that, it's sad. So let's improve performances. And we know how to improve performances because we did this lesson about performances. And there is one main thing we can improve. And we're going to see that by using Spectre.js. But at this moment when I'm recording this lesson, Spectre.js isn't available anymore on Chrome. So it's still available on Firefox. Let me check. We can just do like a Spectre.js Chrome. Please be available. No, see. So right now it's not available anymore. I hope when you will do this lesson, it will work again. But right now it's not working. Do not worry. Spectre.js is also available as a dependency. And you can find it, yeah, use the link. So as always, below, use the link to Spectre.js. Now it's not the Chrome plugin, it's the GitHub page. And here it is. You can just add it to your project. So npm install Spectre.js. It's already in the dependencies of this project, so you don't have to run this. And we can start it using this. And it will run inside our JS application. And it's the exact same thing, so it's gonna be fine. So if it's still working with the Chrome, click here, click on that. All right. If you get a 404, do as I will do now. If not, use the plugin. And the plugin looks, I can show you because mine is already installed, so I have it right now. So it's this one. So it's a Chrome plugin. I click again, and I click on this red dot. All right, so if you have it already, just do that. Click on the extension, click again once it's green, you get this, and click on this red button, wait a few seconds, and you will get the result. By the way, what we want here with Spectre.js, in case you don't know already what is Spectre.js, even if we learned it in a previous lesson, it's to monitor every steps to do one render, one frame of renders. So for us, it will take this frame here right now and tell you all the steps to render what you can see in this frame. All right, let's go. So if you can't have this Chrome extension, simply add this code, all right, at the top or anywhere. We can do like Spectre.js, like this. Just add the code here. So const Spectre, we are just requiring it because it's not working with the classic import. I'm going to do it with you. Const, let me get rid of this. Spectre equal require. So it's common JS way of importing stuff. which is kind of sad. Spector, I just used the what I saw in the GitHub page. Spector equal, oh, I did a mistake. Yeah, don't do I forgot the const here. So const Spector, I should not have just copy. Let me check. Did I? Oh no, they did it right. It's my fault. Sorry, my bad. New Spector dot Spector. That's a lot of Spector. And you can choose to display it, display UI like this. All right, so we import it, we instantiate it, and we say show us the UI, which is this, which looks like the plugin we just saw. All right, once you have this window, you can just click on this red circle, and this is the result. This is one frame, so one render, and all the steps to get there. And as you can see, we are drawing the trunks and the logs. Let's move forward. The fences, so all the wood. It's strange, it's in this order. The metallic parts, the rocks, the grass, and it goes on and on. You can see here and here. It goes on and on and on until the end result. And you can have somewhere, where is it? Yeah, right here, you had 173 steps. It's not that much. We can do much more, but we can do better. All right, so we are going to do better right now. Keep this open. No, actually, you can't keep this open because it's the same page. You can click on the close button. You have to increase the size of the window if you can't see it. So remember, 173. Let's improve that. The idea is that we can merge almost everything. We don't need this fence to be separated from this trunk. By the way, this fence, this plank, it's in the same geometry as this plank. It's in the same geometry as this pole, and it's not a problem. And we can put everything from the baked object, every baked object inside the same geometry. And this is exactly what we are going to do, and it's going to get drawn in one row, which is just awesome in terms of performances. You will improve the performances as hell. It's going to be one big geometry, which is just fine for the GPU. One big geometry is so easy to do, even if there are thousands and thousands of vertices, and one texture. The texture is big, but it's just one texture. Okay, let's do that. So get back to Blender. I hope you didn't close it. And what we're going to do, let me check the order. Yeah, okay, that's it. First, we don't want to merge the emission, all right? Because those have specific materials, specific names. We don't want to merge them. So make them unselectable. Make sure others collection is not selectable. Create a new collection. I'm going to call it merged. Usually I do this. Select everything. Do not move everything in the merge collection because we want to keep those in case we want to do some changes. All right. So don't destroy all what you did. You won't be able to do changes. So duplicate it. Right click to put it where it is by default. And now you're going to press M in order to move it to another collection. And I'm going to move it to merged. I do it again. I make sure emission is not selectable. Others is not selectable. I created the merged collection. I select everything. You have to make sure that one of your object is outlined, is active. Yeah, so just shift click on any object, so I can use the grass. Duplicate everything. If you move, well, it's going to move, but I want it where it is by default, so I'm going to right click like that. So right click. And it's being duplicated, but it stays at the default place. Do not touch anything. I mean, do not click anywhere. Press M and choose merge. So you duplicated everything and put it inside the merge collection. And right now, when everything is being selected, just press, so not everything, everything we duplicated is being selected, just press Ctrl J, like join. We are merging everything into one object. See this one object. This is our merge version of our very complex scene with a lot of objects. So what I can do here, so I will get back, I'm going to deactivate all those collections. So the fences, trunks, floor, axe, pole lights, rocks, and portal. I keep the emission, yeah. I can keep the emissions, not a problem. And can we check the result? Everything is still working, which is kind of strange because we merged everything. It's a feature, a great feature, but I don't like it in Blender, is that you can apply multiple materials on one object, one geometry. It's kind of weird. I don't recommend doing that, but because it's going to get really messy. And when you export this, if you export the material, which is not our case, but still I want to show you in case you want to export materials, you will get different objects. So we get one for each material. So one for everything rocky, one for everything like wood, grass, and rock and metal. All right, which is sad. We want to merge everything. If you don't export materials, remember there is a little select menu. Well, it will be one object, but still I want to show you that. It's also a great opportunity to show you something I really like. It's when you remove the materials. So this is in the end what I wanted to show you. You can remove the materials. So select the merge one, go into materials and remove those materials. And as you can see, there is multiple materials on the same object. Press minus, 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 and minus, and you get this. And I just love this result. All right, it's just great. Let's see the result. So no, I don't want to do that. You can do a render. The problem is that the compositor is currently doing, the denoise and stuff like that on the texture. So I should not have start a render. Don't start the render. You're gonna have to wait for it to finish, which is awkward. Okay, good. So in the compositor, remember you have to mute those, unmute this one, and put the image here. All right, and it's going to do a render. And you also have to change the resolution if it's not the right resolution. And here is the result. So it's going to take quite a while. I'm not going to wait for the end of the render, but I really like to see this version, like kind of pure, no materials. I think it looks just great. So yeah, yet again, just do a render, share it, and yeah, it's really cool to see it without materials. All right, cool. We are almost done. What we're going to do is rename this one. Yeah, we're going to rename it Baked, like this. So now the name is Baked, so that we can target it the same way we targeted the pole light and the pole lights and the portal light. So name it Bake. I think we're ready to export everything. Yes. Yeah, we have it. So what you're going to do now is make sure you cannot select the old ones. All right. Make sure you can select the emissions. So click on this button to enable selection of emissions. So as you can see, the portal is being selected just like the pole lights lamps, like this. So everything is selected. Yes, I'm quite sure it's fine. And you're going to export it again. So right now, all we have is 4 objects, and these are the default parameters. Pause the video if you're not sure. This is what I was talking about, materials. We are not exporting the materials, which is why we don't really need to remove those materials from the merge version. So just make sure this is on no import. And you export, same name, and you go back here. So is everything working? Yes. Do we have errors in the console? No. Let's run one spectre and see how fast it was. And look at that. That's all. 16. We went from 173 to 16 with the same result. See how important it is to merge things? You could say, yeah, but it's a big geometry. Yes, so we have as much vertices, but it's going to be rendered in one row, and be aware that the GPU can handle like huge, very complex geometries, it's okay. With the millions of vertices, it's okay. Here we only have maybe like 4,000 vertices, something like that, so it's fine. So yeah, so here is the result. So the default one, so this is the initiation. Yeah, the first one is just about clearing stuff, because WebGL needs, the GPU needs first to clear the previous render. The second one is the whole scene without the lights. Next one is the portal light. Next one is the pole light A, and next one is the pole light B. We could have merged those, but if you want different colors, you can. All right, and it's not going to make a huge difference in terms of performances. I think we are done. Let me check. Yeah, we did that. We export it again. We test with Spectre, and it's all good. Yes, we can do one last more change because it's not really optimized. Here we are traversing this whole scene just to change one child, because we only have one baked child. So we don't need to traverse the scene. We can do just like we did for the portal light and the pole light. So let's go. What I'm going to do is remove this part, keep the scene add GLTF scene, all right? For me, it's at the end. Yeah, it's fine. So I'm going to get it. So const, I'm going to call it, to name it baked mesh. And I'm going to be lazy and just copy and paste this part. So GLTF scene children fine. I go through all the child, and if the child name equal baked, this is the one I want, and I will assign it into the baked mesh. Before changing the material, I can just make sure it's working. It is. I have my mesh here. So this is my mesh. All I need to do now is change the material, and I already have this material. It's going to be baked mesh material equal baked material, like this. And it's very simple, very optimized. Performances are great. This will work on your old smartphone, maybe not like the old Nokia 3210. And we can remove Spectre.js. Yeah, all good. But it's not done. In the next lesson, we are going to add cool details, because it's great to be able to turn around. It's already like a cool bonus, but we are not using the real power of WebGL to add some cool stuff that we cannot do easily using classic software. So we are going to add fireflies and a cool pattern in the portal. By the way, you can't see the back of the portal. It's something I like, because I think it's funny to be able to see like this, like if you're from the other world, you can see this scene. So I would have keep it this way, but obviously you can make it visible by changing the, it's going to be here, and doing side 3.double side. All right, so it's up to you. Do you want to see the back or not? And right now it's working this way. It's up to you. You can do whatever you want. Actually, it might be a bit better. I'm not going to do it. All right, cool. See you in the next lesson.